All right, let's finish this lecture. I can get my voice back. There we go. Okay, so part one, we went over this already, the Java Servlet. Well, we actually only covered transaction management, which was the first part of this lecture. The second part is the web tiering and the Java Servlet pages, which is part two. Around slide 40-something is where I left off. 42, thank you. Yes, here we go, web tiering. So when we start talking about servlets, we're starting to get into the web tiering. So a J2EE application web tier, it makes the application's business logic available to the World Wide Web. So most people from a consumer point of view have no idea what you're logging into when you go to a URL and you go and you log into an application. What you're usually logging into is a front-end web server. Web server is doing nothing more than handling the incoming client connections. And then behind the web server, we've got an application server. Behind the application server, we might have a database, we might have another server, we might have a file server, any sort of an arrangement. And so the web tier handles all of the J2EE application communication with the web clients, invoking business logic and transmitting data in response to incoming requests. So the web tier, the web itself, let's get the web tier. Just think about, it does nothing more than handle clients. And you think about it, well, in the old days, we had one server people would log into and it would handle everything. It would do the application, it would run the programs, it would have everything on there. Which, you know, if you're scaling and you're going to handle a lot of simultaneous clients, why not put together a web tier? And the web tier is just going to handle the connections, which is a lot of traffic to begin with, and then have that divert the traffic to other servers. So it's kind of like the gatekeeper or the front end into the applications. So the purpose of the web tier is a server in the web tier processes HTTP requests. If you have thousands and thousands and thousands of clients logging in, it makes sense to have your separate web tier. So in J2EE applications, the web tier usually manages the interaction between the web clients and the application's business logic, meaning it's the router, it's the tier that's routing the traffic to the applications. And it typically produces HTML and XML content through the web tier and can generate and serve up any one of these content types, or any content type, I should say. But we're usually seeing XML and HTML or XHTML through this web tier. So while the business logic is often implemented as enterprise beans on another tier, it may be implemented entirely on the web tier. So you could stick everything all on one tier and just have the different interfaces. So web tier functions. Web tier typically performs the following functions. We have web-enabled business logic. So it's the web tier manages the interaction between the web clients and the application business logic, generates dynamic content. So it generates in terms of video, HTML, sound, audio, scripts, all sorts of things can run to generate content to give to the client, and presents data and collects input. So it can be used to translate HTTP put and get actions into a form of business logic that understands, you know, basically presents results as web content. More functions of the web tier. It controls screen flow. So the logic that determines which screen, which is going to be the user interface, that is which page is displayed next, usually resides on the web tier. Because the screen flow tends to be specific towards client capabilities. So if the client is a mobile client, the client's coming from another computer connection or another server, maybe without a UI, the screen flow and content is going to be determined by the web tier. Maintains state. So the web tier has a simple flexible mechanism accumulating data for transactions, interactions, and user sessions. So it supports multiple and future clients types as well. So extendable MIME types describe web content, so web can support any current and future type of downloadable content that might exist. So it's expandable, hopefully. It may implement business logic, doesn't have to, but it might. While many enterprise applications implement business logic in the enterprise being web only, low to medium volume applications, simple And simple transactional behavior can be implemented using the business logic entirely within the web tier. It does not have to be brought off onto different servers. So traditional web tier technologies, this is the more interesting part. So earlier releases of the World Wide Web relied on HTTP servers to serve static HTML pages through HTML browsers. When you set up a web tier, you're pretty much using Apache if you're on the internet these days, or you're using another server technology, and what you're doing is you're opening up a port and you're making a directory available, and the directory has a bunch of static pages on there, HTML pages. You're still doing the same thing even when you're using JSP, because that HTML page is going over and running a bean, or it's running a script, Java JSP script, getting something maybe dynamic from the server and then retrieving it back. So you quickly become clear that dynamic content generated on demand would make the web platform delivering applications as well as content. So we need that dynamic behavior. Several mechanisms were deployed to allow web servers to generate content on demand, all of which let the web server functionality extensions, all of which can be used through web server functional extensions. This is the opposite of CGI. So originally we started out with what was called Common Gateway Interface, which I'm not going to read you the content on the slide, you can read it yourself. But what we were doing in the past was we had this, call it a port, call it a directory. It's an entryway from the web server into the server to run programs. And the programs that were running through the CGI port, or gateway, call it that, generated content that was sent back to the client through this gateway. And it was a way of creating dynamic behavior. Thing of the past, and then as I mentioned in our first class meeting last session, it creates a lot of traffic, creates a lot of processes, creates a situation in which you don't have very good server utilization, because it's bogged down. Each client that connects to the server creates its own process, creates its own application instance, and makes it so that the server is not really managing the clients as a client, it's managing it as an individual request. So better technologies came around. Also CGI was not as secure as the J2EE environment is. Doesn't provide any type of security features. In fact, it opened up the door, so pretty much any application that was running in that CGI bin directory, or was loaded in that bin directory, was available. So it was very simple though. It was very easy to use, although it did not provide very many features. So the web tiering technologies in the J2EE platform go above and beyond the CGI capabilities and make it so that the server is acting a bit more streamlined and a bit more efficient. So in terms of the web tiering, it provided the benefit of the client-side scripting using compiled Java classes and standardized secure vendor-neutral environments. The web tiering also is a collection of web tier components, content, configuration information that operate as a single unit, and it serves up to multiple clients. It's not a one client per process situation. So runtime support environment for the web application is called a web container. So there's some more terminology for you. So the web container is that runtime support environment for web applications. Think of it more like the web tier has a container. The container is carrying all of the web applications. The web application archive, the .war file, if you've seen those before from a programmer's perspective, combining file contains all of the classes, resources for the web application, kind of creates a container for it in itself, along with XML deployed descriptor that configures the application so the application can run. And kind of just a compressed file, actually, the WAR file. Makes it so that you don't have to carry over all the images and scripts and code and pieces. It's just one file that contains all of that stuff, all compressed together. So in terms of the technology, the platform specification defines the contract between the web container and the web components themselves, defining the life cycle of the component containers, the components themselves, the behavior, what must be implemented, security, all sorts of different features that go along with the delivery of those applications. So platform specifications are also defined in two types of web component technologies, and here is how this fits in with J2EE. So the web servlets and the server pages technology. And for anyone who's familiar with ASP from a Microsoft's perspective, this is the equivalent. So JSP and ASP are pretty much the same thing, active server pages. One's made by Microsoft, the other one's made by well, Oracle now, but it used to be Sun, the Java equivalent to it. We don't have servlets, though. We don't have servlets in ASP environment. The technology of the servlet is equivalent, however, to the server in terms of the ASP equivalents. So let's talk about what these things are. Servlets and JSP. A servlet is a Java class that extends the J2EE server, produces dynamic content in response to a request from a server. The server passes a service request to the servlet through the standard interface, which is the JavaX servlet, which every servlet must implement. So think of servlets as classes that extend server behavior. And they're small programs, sort of like beans, but beans are resource managers. So servlets are classes that serve up information in response to requests from clients. A JSP page, and JSP is a scripting language. So, but JSP itself stands for Java Server Page. So the page itself is like an HTML content. It is an HTML page with specific markup that provides customizable behavior for generating dynamic content at runtime. So it's a script / a page. So when you load up, index.jsp, it's giving us the HTML interface, it's giving us the scripting, it's giving us everything we need to communicate with the server to process the dynamic behavior that we're interested in getting. Otherwise, we'd just do it in HTML and leave out scripting languages in general. So JSP page is usually translated into a servlet when it is deployed. It's created into the servlet. And the technologies provide document-centric. Document-centric is another vocabulary word for you, which is why it's in blue, rather than programmatic way to specify the dynamic content. So document-centric means that the code is inside the document, sort of like a scripting language. Well, it is a scripting language, but it's specific towards the document in terms of the content. Now the web container, the J2EE web application itself runs inside of the servlet web container. It's just another word for the servlet server, but web container sounds a little bit better than a servlet server. It's a little bit more specific, so it's the container. It manages all the components, the life cycle of the components. It's kind of like the RMI registry of the RMI environment, where you register objects and the objects reside. The servlet, the web container registers the servlets and keeps the servlets instances contained, so there's only one instance of each object that's contained. And when the servlet loads up, each object is instantiated and becomes available to be serviced. So the container manages the component lifecycle, dispatches service requests to application components, and provides standard interfaces for data, such as session data, information about the current requests, and things of that nature. Retains state of objects as well. So the web container provides the consistent interface and the components that it's going to host, depending upon what's loaded. So web containers are portable across different application servers. You just load the file in there, the Java program in there, and it becomes a servlet. So packaging and deployment of web applications are standard. The web application can be deployed to any J2EE server without compiling the code or rebuilding the application archive. So when you're just moving it from one location to another when you start installing it on different servers. So Java servlets. So Java Servlet is a Java class that extends the compatible web server. So it's extending web server. Think of them as Java classes that generate dynamic HTML content using print statements, which is kind of interesting. Similar to CGI interface, where that supported the interface between the web and the applications themselves, supporting the request and response from a programming model. Actually, in the old CGI days, you used to write a Perl script or a C program that produced HTML output, and you sent the HTML output from the program through the web, through HTTP, which is the HTTP protocol onto a client in a client browser. It's actually the same concept. So really, Java servlets are equivalent to CGI in a lot of different ways. It's just a modern day technology versus an older one. So servlets offer some important benefits over the earlier ones. Obviously, security is a big one. Compatibility with Java classes and Java in general versus, CGI is good for Perl, well, Perl was the biggest language used for it, but C++, traditional style programming languages. For the Java support, the servlets provide a lot more in terms of the capabilities. Servlets are safer than extension libraries, because Java, the virtual machine, can recover from a servlet that exits unexpectedly. And we've got garbage collection. Actually, we have the JVM. So if we have the JVM running, it's taking care of its instances of objects. So it makes for a more efficient environment. Servlets are portable, both at the source code level, because the Java servlet specification, and they are binary level because of the byte code that we create into the class file that gets loaded into the server. And they also provide a richer set of standard services than the other wider adopted server technologies. So JSP, Java Server Pages. There should be a space here, actually. JSP technology extracts servlets to a higher level, so directly competes with Microsoft Active Server Pages, ASP. That's what I was saying before. ASP is the Microsoft equivalent to the Java JSP. And the page itself is a document containing fixed template text plus special markups for including other text or executing embedded logic, XML, or any type of interface that's going to be combined. So the fixed template text is always served to the requester just as it appears on the page, like traditional HTML. And the special markups come in 3 different forms. We can have a directive, a scripting element, or a custom tag. So if we create some custom tags, we can send data back and forth. So think of JSP as inside-out servlets, because they're sort of like the output of a servlet, if you think about it. So it's kind of an inside-out servlet. Benefits of JSP. They are easily combined static templates, and you can easily combine HTML with XML code fragments with code that generates dynamic content, images, scripts, you can mix and match technologies in with a JSP page. They are compiled into servlets when requested. So the page authors can easily make updates at the presentation code, can be recompiled, precompiled if desired. They're easily changeable. Well, you get all the benefits of an HTML page, essentially. The JSP tags are invoked for invoking Java Bean components. Manage these components completely, shielding the page author from the complexity of the application logic. Well, you're using a scripting page to make an instance of a Java Bean, or to not make an instance, but to call features, run methods on a Java Bean, which is kind of interesting. So it provides the interface between the HTML and the beans. Developers can offer customized JSP tag libraries, and the JSP pages themselves have all the benefits and technologies of Java technology, including robust memory management, security, and everything else that comes with Java. So it provides enterprise class scalability and performance. So some of the speed improvements that we can achieve through using JSP, separating the content generation from the presentation. So the presentation is in the HTML format. The content generation can be from Java Beans, from servlets, from anything on the server. So we're using the JSP technology, the web pages, using XML, HTML, everything, tags to design and format the results that appear on the page. If the core logic is encapsulated in tags and beans, then other individuals such as webmasters and web programmers can edit these pages without affecting the generation of the content, because content's being generated on the server. So JSP makes it a little bit easier for non-programmers, for more web application people, to actually kind of update and customize the user interface, or the user interface through the HTML mock-up, the presentation of the data. It also emphasizes reusable components. So most JSP pages rely on reusable cross-platform components, or Java Enterprise Beans, to perform more complex processing required for the application. So it mixes and matches and uses the best of both worlds. Unlike a true scripting language like PHP or Python that is basically running scripts, which is code that is producing results. In the JSP world, we're just calling components, and we're calling things on the server through the web page, rather than relying upon the language itself as a script to generate its own content. It's using other components, so it's kind of a hybrid. It's not really, I don't know if I would call it a scripting language. It's more of a hybrid interface to Java components. So developers can share and exchange components that perform common operations, or make them available to larger users and customer communities. So the component-based approach speeds up the overall development, lets organizations leverage their existing expertise and development efforts, and basically reuse stuff. It also simplifies page development with tags. Tags is kind of an easy way to, anyone who's ever tried HTML knows it's kind of easy, actually, a little tag interface. So you put that into a programming environment, and it makes it easy. So web page developers are not always programmers familiar with scripting language, so encapsulates functionality required for dynamic content and easy to use JSP-specific XML tags. So it uses XML-like tags in terms of its formatting. Standard JSP tags can access and instantiate Java Bean components. So set and retrieve Bean attributes, download applets, perform other functions and other things during time-consuming, otherwise doing things that would be otherwise difficult to program in, or might be also time-consuming. So it kind of saves a lot of work and energy in terms of just being able to use tags to initiate behavior. JSP technology is also extendable through development of customized tag libraries. So third-party other people can create their own tag libraries for common functions, incorporate them in. So this lets web page designers and people work with familiar tools and constructs such as tags, and to perform sophisticated functions. So here's a simple example. What does this JSP look like? Here it is. So here's a simple application that utilizes JSP. From the browsers, this is where we're going to actually, the client is going to actually call this JSP page. It's going to have HTTP, HTML, XML protocols being used from the browser to access this JSP page. And the content of the JSP page might actually have HTML on it. And the HTML, or might actually be separated out into an HTML page that calls the JSP page. The JSP page calls the Java Bean out here, and the Java invocation method, let's say for JDBC or something, may also work with other technologies as well. So this model basically replaces CGI bin concepts with a single JSP page. So in the CGI bin era, we had a browser, and this was a CGI bin over here, and it went through this gateway and it ran a program out here. So now this kind of represents the bin directory, actually. It represents the gateway in a lot of different ways. So the model has the following advantages associated with it. It's simple and fast to program because these are all in text, they're not compiled, although you can pre-compile the JSP pages. The page author can easily generate dynamic content based on the request of the state of the resources. And the architecture works well with many different applications, but it does not scale for a large number of simultaneous web clients accessing scaled scarce enterprise resources. The resource, you still need to have available resources for scaling. And as an example, if the JSP accesses a database, it may generate many connections to a database, which can affect the database performance, versus calling to a bean and having the bean do the generation of the dynamic content coming from the database. Because you're still working with a one client request per process being created. So in terms of a large-scale development, you might end up with a not so efficient running server. Here's an example of a flexible application with Java servlets. So we have the client, we request to the servlet, JSP comes back with the response to the client, and we break it out into separate different JSP pages and separate different servlets so that we can basically have the servlet do the work and use the JSP to deliver the content back to the client. This is what you're going to be doing in one of the assignments that we have for this class. Actually, the assignment's not too hard. You're going to create an index HTML page, a JSP page, and you're given the code for a servlet, I believe, and you put the pieces together and you run it. It's not that hard of an assignment. So web-based clients may make a request directly to the Java servlet, which actually generates the dynamic content, wraps the results into the results bean, and invokes the JSP page. And then the JSP page accesses the dynamic content from the bean and sends the results through the HTML as HTML back through the HTTP protocol. So the approach creates a more reusable component so that can be shared between applications because you have the servlets running rather than pages, and may implement as part of a larger application. So it still has scalability issues in terms of handling connections to enterprise resources such as databases. So here's a JSP scalable processing with enterprise bean technology, Java bean technology. So what we've done here, started out with a simple JSP page, no servlets, no beans, and the JSP connects to the JDBC and gets information from the database. Here we added a servlet component, let the servlet do the work, and then it's kind of sort of like the RMI concept. There's only one object, one instance of that object created. Cuts down on the traffic a little bit. And we'll break it out a little bit further, scale it down, and actually add a bean to it and a servlet. Then we've got a good running kind of system. And that's one of the reasons why this technology is very popular. It's very flexible. You can run multiple different tiers, you can run multiple different components together, you can configure it for optimizing the resources that are available. So JSP page here can also act as a middle tier within the enterprise Java bean architecture. In this case, the JSP page interacts with back-end resources via the enterprise Java bean component. So we have the browser, we have the JSP going through either RMI or another technology and accessing the enterprise Java bean. And the enterprise Java bean is going to be a Java program. Actually, all this stuff is Java program. The only thing that's not a Java program is HTML pages and JSP pages. And JSP pages look like ASP pages. They're just text pages with tags in them. So the Java bean, enterprise Java bean component messages access to the back-end resources, which provide scalable performances for a high number of concurrent users. You're going to go through this technique, use an enterprise bean if you're going to have a larger number of users simultaneously connected. So for e-commerce, for other applications, the Java enterprise beans manage the transactions and underlying security. This simplifies the JSP page itself, makes the page not as feature-rich. Instead, rather, we have the bean doing most of the work. The model will be supported, will be supported by the J2EE platform, or is supported, I should say. So, in a nutshell, this is the JSP versus the servlet, and then along with the servlet, and along with Java enterprise beans as a technology, which is how it's basically being put together. Now we have this old design pattern called the model view controller. And you're wondering, well, how does this fit in? It actually, this architecture here actually meets the design pattern for model view controller, which is one of the oldest object-oriented design patterns on the market. still being used. In fact, it's very popular for iPhone development, for all sorts of object-oriented design in terms of the methodologies. What we have in this example is the Enterprise Information System, the EIS down here. We have a classic web customer, a wireless customer as an example, on a mobile phone, an administrator, a supplier, maybe a B2B agent, maybe going through some other application, some interface. And then we have the different views. So the model itself, we have the data, the view, or the user interface to the data, and then the controlling of the data, which is the three components of model view controller. In terms of the view, the HTML view for the classic computer user, the WML, the web markup language for your web user that's going to go on a phone. Actually, it's kind of interesting. This is more web component, web views are more HTML based these days because, in the old days the phones were smaller, were more mobile. Now we got phones that are as powerful as computers and tablets and things like that. So it's straight HTML. So WML had a niche market for a while there, but we're still looking at development in an HTML and an XML. So because the screens are bigger now, processors are stronger. We don't have to worry about the mobile drawbacks that we had before. We might have a swing or a JFC in it for the administrator, Java swing, or XML based. Especially on this end here, if we're going from an application to an application, it might be an XML based web service that might exist. And it's all going in to this enterprise application. So an online store may require HTML front end for customers, WML for wireless, Java Swing or Java Swing clients for administrators, or XML for web service suppliers. In terms of the design pattern, the model itself encapsulates the application state, responds to the state queries, exposes application functionality, modifies views of change and stuff. And the view itself renders the models and provides the UI, requests updates from the models, sends user gestures to controllers. The controller defines the logic, the application behavior. It maps user actions to module updates, selects view of response, maybe for the functionality. So you can kind of see how the different states work together. The state changes between the controller and the model, and between the query from the view to the model around. So this is really what's meant in terms of the model view controller, is that design method, or pattern, I should say. And there are not too many design patterns out there, actually, but this whole enterprise V and the whole servlet follows through model view controller, if you think about it. So separating out business logic from presentation. In terms of separating out the business logic from the presentation, has several different important benefits to it. Well, not only can you make the UI and the presentation available towards web programmers and people who aren't, people who aren't necessarily programmers but more designers, and then you can separate out the functionality so that the designers are doing the artistic work and the programmers are doing the functionality, creating that dynamic content. We have some pros and cons to it. We can minimize the impact of change. So business rules can be changed in their own layer with little or no modification to the presentation layer. So it's kind of like the pros and cons, or the benefits, I should say, for modularizing or for creating separate objects for things. Obviously, the more modules you create, the easier, the more flexible, the more reusable the design is going to be. So increases maintainability if we separate out the business logic from the presentation layer. And the business logic itself is expressed in separate components. May be accessed referentially, can be modified in one place in the source code, so it produces behavior changes anywhere the component is used, and the logic itself is only housed in one area, so it can be easily modified for all functionality that uses it. Provides client independent and code reuse as well. Independent, intermingling data presentation and data logic for particular clients of different types. We can also separate out the developer. So separate business logic presentation allows developers to concentrate on their area of expertise, as I mentioned before. Web designers can concentrate on artistic and UI, whereas programmers can actually look at the business logic. So here we have our application complexity versus robustness. So complexity versus robustness in terms of what's going on. And you can actually kind of see how the technologies kind of fit into the big picture. HTML pages, not very complex, easy to do, not very robust. You can't do very much with HTML. You can pretty much just show content to the user. So basic JSP pages and servlets provide HTML pages, JSP pages, and servlets. A little bit more complex, however, a little bit more robust. Gives us more scripting capabilities, gives us more functionality. JSP pages with modular components, a little bit more complex, again, more robust in terms of its ability to provide HTML pages, JSP pages, servlets, Java Bean components, and then customized tags. And then on the far right here, the JSP pages with modular components and enterprise beans. If we combine all of it together, then we get the best of everything along with the enterprise beans that go along with it. So it's basically a combination of mix and matching. What makes these technologies kind of interesting is that they're flexible. You don't have to use enterprise beans. You don't have to use servlets. You don't have to use JSP actually, but you can, and you can mix and match all of the technologies together. And then it becomes, a matter of choice and a matter of design preference. So some designs actually lend themselves better to certain configurations. So the model number 2 recommended here for the model view controller architecture, if we have the web browser out here, makes a request, we have the controller servlet, the view, which could be the JSP modules, and instantiates a model itself. So we have the model view controller in here, where the view is used from a JSP perspective, to send a response back to the web browser. The web browser makes its request to the controller, the servlet, and the servlet would instantiate a Java Bean or use a Java Bean, and the Bean would actually attach to the enterprise server. And in this example here, we've got a persistent server with a database on it. The Bean here would be in charge of requesting information using a JDBC connection to the database. So we can kind of see this again, another picture of the model view controller architecture put into perspective. This actually kind of gives it a nice kind of layout, I should say, in terms of taking the design pattern and applying it to web services. In the model number 2, which is this one here, model number 2, it integrates the use of both servlets and JSP in this mode. The JSP is used for the presentation layer and the servlets for processing the tasks. So the servlets out here would be processing the request. The JSP would be used to send stuff back. So you can sort of see how the technologies are working together. And the servlet acts as the controller responsible for processing the request and creating any of the beans needed for the JSP pages themselves. So the controller is also responsible for deciding to which JSP pages to forward the request to. And then the JSP pages retrieve the objects created by the servlet, extracts the dynamic content for insertion within the template itself. So how do JSP pages work? So we've talked about the technologies in terms of putting it together with the model view controller design pattern, and how the pieces have different responsibilities. Big question to consider is, what do these JSP pages do? They're not scripting pages, they're not applications, they're not fully presentation. We have HTML that does that. How do they fit into the big picture? Basically, they're web pages with traditional HTML and bits of Java code mixed in. Not JavaScript. That would be JavaScript on a regular HTML page. So the file extension of the page is a .jsp, which tells the server that it's a JSP page, kind of like an ASP extension on a Microsoft server. So rather than HTML and HTML, JSP tells the server that the page requires special handling that will be accomplished by the server extensions or a plugin in the browser or plugin on the server. So when the JSP page is called, it will be compiled by the JSP engine into a Java servlet. So the JSP engine actually creates the servlet from the page. So, which is kind of like the reason why it's called a servlet and not a server. It's a smaller piece of the server, and they can be pre-compiled ahead of time by being loaded on the server, or they can be called from a client and then loaded at runtime. At the point that the server is handled by the servlet engine, just like any other servlet, we can actually create servlets that are pure Java code without any HTML or XML markup and load them into the servlet, and they would be considered true servlets. So servlet engine then loads the servlet class using the class loader, executes and creates the Java HTML and sends it to the browser. It's kind of like running a Java program through a web browser. That's what it is equivalent to. Servlet creates any necessary objects, writes any objects as a string to the output stream in the browser. So the next time the page is requested, the JSP engine executes the already loaded servlet unless the JSP page has changed, in which case it automatically recompiles the servlet and then executes the recompiled page. So you got the best of both worlds, really, because you got something that's dynamic that can change, that's not, that's in static form. I mean, it's a text page that's loaded from a browser, yet it turns into an application, and it contains Java code. So what we're looking at here is a request, and this is a form. You can't see it. It says user, what does it say? User task request form. It's a form somebody filled in. They pressed a submit button. The request went to the web server. The web server used the server extension to load up the JSP engine to compile that page to a runnable program, ran it through the servlet engine, sent it back to the server extension, which sent it back to the web server that sent the computed output to the client, which is really how JSP is working. So and that's why I say it's not really a scripting language, because a scripting language would run right here. Like if you loaded PHP or Python or Perl, it's loaded from either the web server or an application server. Usually it's the web server. And the script itself is running the script, and the script itself is sending the feedback from web server here. So the server extensions and servlet extensions actually compiles the page, turns it into an object, and treats it like an object that can use other objects on the server, which makes it a little bit more powerful from the server side. The servlet's job. So what are the functionality that the servlets actually perform? They read explicit data sent from the client, the form data. They read implicit data from the client, request headers. They generate the results. They send the explicit data back to the client in an HTML format. They send implicit data back to the client, status codes and responses to those headers. So here we have the client over here, or the end user, who's contacting the web server. The web server is contacting the database, legacy applications, Java applications, B2B applications. And this is just a list of the technologies that the web server can actually use in terms of the JDBC, RMI, XML. So we're not going to hit too much XML in this course, but XML is just like HTML in a lot of ways. Except for HTML is used to mark up text, XML is used to mark up data, so you can transport data back and forth. But XML is actually not too bad. I mean, it's as easy as to program as HTML. And normally you don't write an entire program in XML either. It's used for markup of the data, so you can send it from a server to a server. So the need for JSP. So with servlets, it is easy to read form data, read HTTP request headers, set HTTP status codes and response headers, use cookies and session tracking, share data among servlets, remember data between requests, get fun high-paying jobs. But sure is a pain to use those print line statements to generate HTML, maintain that HTML. Well, because we're still working with a text page, and so we're still using primitive CGI kind of interfaces where we're printing the HTML output, so our print lines are actually generating HTML code. Here's the JSP framework in terms of the idea. Use regular HTML for most of the pages, mark servlet code with special tags, and the entire JSP page gets translated into a servlet once, and then the servlet is what actually gets invoked for each one of the requests. And then here's kind of a sample JSP page here where we've got a HTML in there. And we have a link in here. This is JSP style. CSS is going to use a CSS sheet for that. Order confirmation. Thanks for your order. Here's the request. Get parameter title of the requests. The rest of the information that might be in the HTML format that's going to be sent back. Advantages of JSP over competing technologies versus ASP or Cold Fusion. Better language for dynamic part. Some might argue ASP is pretty similar in functionality. Portable to multiple servers and operating system. Yes. ASP only works on Microsoft servers and Microsoft environments. So JSP is actually more portable because it works on everything except for Microsoft. So it's kind of like the opposite. Versus PHP, better language for dynamic part. You can run Java programs from JSP. You can't do that from PHP. Better tool support, yeah. And the environment's better. There's hardly very many tools for PHP programming. It's all done in Notepad these days or text editors. Versus pure servlets. More convenient to create HTML code than Java source code. If you're creating a servlet, you're going to be writing it in Java. Which is easier, HTML or Java? Some people might argue and say Java. I don't know. I don't know. It depends on what side of the fence you stand on, but HTML is pretty easy for non-programmers. You can use standard tools for it. Dreamweaver, stuff like that. You can mix in. You can divide out and conquer. JSP programmers still need to know servlet programming to the most part. Because you need to know what you're calling. You're putting code in the page that's not maybe Java code, but you're still trying to make instances of methods, instances of objects and call them and run methods on objects. Versus client-side JavaScript. In a browser, JSP runs on a server. So we have compatibility mostly. Do not overlap with JSP, but you can control the servlet, not the client. And you also have a richer language on the server. JavaScript is functional to a certain point. Great for client-side applications, but you're giving everything to the client. So your code is essentially, through JavaScript, is running on your client instead of running on your server. It means you're freely giving away the source code with the HTML page. So JSP versus server-side JavaScript, Livewire, broadband, richer language. Very similar but very rich in terms of its features. Versus static HTML, well, JSP is giving us dynamic features and it's adding dimensions for future features. No longer an all or nothing decision. We can use combinations of different technologies together. So here's an example of a JSP. It's called the JSP expressions. We have keywords here that are going to be used in your description. Quick example. Here's a little style sheet that can be used with it. So you can use in a JSP page. You can use CSS. You can use HTML. You can use Python, PHP. You mix and match. It's all in one page. It's all text format. So you can mix and match technologies. And look at that. We're using Java util date. So we're using Java programming language in a JSP page. So, which comes in handy if you know Java. So session, get ID, set ID, all the different parameters that can be run. And here's the results of this page, and this is what the page started out with from an HTML perspective and from the JSP code that's put in there. And the page looks like this. And you can see that the page runs with expressions.jsp. It's a file extension. And it's running, a Java util date So we have the date from a Java command, and this is just Java source code, new Java date. So imagine being able to write Java source code in an HTML page, and you got JSP. And you know, well, how does it run? Well, it has to go through that server. So the JSP page gets compiled, and it gets processed through the servlet, which is nothing more than a JVM. It's a mobile version of the JVM, server version of the JVM, virtual runtime machine. So this code gets created into bytecode on the server. So on the Java, on the client machine, if they looked at it, you know, they're not going to see it because the page is being loaded from the server. But even if they saw it, they'd see the source code. You know, but they're not going to see. You're not going to put passwords for database logins and stuff here. Instead, this code is going to make an instance of the enterprise bean, and the enterprise bean is going to be located somewhere on the server, and that bean is going to have the password information for the database, and that one's going to be responsible as a resource manager to take care of the connection to the database. So you're not giving away any secrets to the client in terms of security. Most common misunderstandings: forgetting that JSP is a server-side technology, thinking it's a client-side technology. Could be a problem. A very common question: I can't do such and such with HTML. No, you can't. Will JSP let me do it? No, JSP only runs server technologies. It's not going to replace HTML or have you be able to do things that HTML can't do. Why doesn't this question make any sense? JSP runs entirely on the server, so it doesn't change content on the browser or anything that the browser can handle. Similar questions: how do I put a normal applet in a JSP page? Well, you can actually just use the applet tag. It's just like an HTML page. How do I put an image? Well, use the image tag, just like HTML. So, how do I use Java? How do I use Java script, Acrobat, anything? You'll see the appropriate tag. You can embed anything. It's HTML and Java all in one. So you might want to think of JSP as a hybrid interface to Java. It's a non bytecode compiled program that you're writing, and you're putting the text and mixing it in with other technologies, which gives us JSP. Second most common misunderstanding is the translation and request time confusion. So what happens at page translation time? JSP constructs get translated into server code, and the page itself, the JSP, the source code that's written in Java, gets compiled. And the compiled code turns into the servlet, and the servlet runs on the JVM equivalent servlet. What happens at request time? The servlet gets executed. Well, no interpretation of the JSP occurs at that time. The original JSP page is totally ignored at the request time. Only the servlet that results from it is used. So it's kind of like sending a program through source, having it compiled. Once it's out there sitting there, you don't have to look at the source anymore. You're just looking at the executed page that's coming out of the Java, the bean that was created, or the servlet that was created. When does the page translation occur? When it's being run. So typically the first time that the JSP page is accessed after it is modified. So when it's being run. This should never happen to real users. Developers should test all JSP pages they install, hopefully. Page translation does not occur for each request. Depends on which page you're requesting. Only the pages that are being requested are going to be translated and compiled. So it's kind of a just-in-time kind of compilation. And then if the page changes, it's recompiled automatically, dynamically. So JSP servlets in the real world. Let's talk about airlines. Everybody uses it. Delta, United. I can go through the list here, but this is an example of where JSP and servlets are being used right now, because they integrate really well with the presentation, with HTML presentation in terms of a web interface, and gives us that dynamic behavior where the servlet can actually go out and log in and see you know, what flights are available, and then run the queries that are being needed. Financial institutions, financial services also use it. Wells Fargo, American, Bank of America. Banks use JSP with servlets because you're going to have all of the functionality occur on the server, and the servlet works really quite well with a HTML interface, as well as other scripting languages. Just because you're using JSP doesn't mean you can't use everything else. Cold Fusion, and you can use tons of stuff with it. Retail stores use it. So we got Sears, Walmart, and practically every website out there is using JSP and servlets. It's pretty popular, I should say. Google, eBay, eBay, half.com. Netscape, well, I don't think is Netscape still around? Firefox. Actually, that was from Mozilla. Netscape, I don't know. Netscape's a different company. I don't think they're still around. Dice, they're still around. Alright, summary. JSP makes it easier to create and maintain HTML while still providing full access to servlet code. Okay, JSP pages get translated into servlets. They get translated into compiled code. It is the servlet that runs at request time, not the page. The page just gets translated. Clients do not see anything JSP related. They can't. It's hidden because it's running on the server, not running on the client. And you will still need to understand servlets if you're writing JSP. It doesn't avoid you having to know something about servlets. So understanding how JSP really works, servlets codes called from JSP, knowing when servlets are better than JSP, mixing servlets and JSP. So other technologies use similar approaches, but they aren't portable and don't let you use Java for real code. So yeah, this is one of the biggest selling points of JSP is you're writing Java code in it. So if you want to write Java code, you're doing the JSP route. Otherwise, you're going to pick and learn another language, a scripting language to use. Here's some resources that still work. I have tried these. I don't know if this free online book. Actually, let me just see this real quick. Customized J2EE training. The site's still here, and there are some free PDF books on here as well. So the link does still work, which is good. The tutorial here is probably upgraded to a newer version, as Java has been upgraded. Some of the other ones, server-side articles. Let's see if that still opens. Java News, yeah, the links are still good for the most part. Alright, I think that is the last slide, but just let me make sure. Yep, it was the last slide. Alright, so I'm going to end this lecture. This was the second part of Lecture 6 on the JSP, servlets, and Java transactions, transaction management, to kind of complete your background on that. And again, you will have an assignment that you'll need to do that will exercise JSP, but it's not going to, I mean, it's just writing, it's the same as what you've been doing so far. It's just writing Java code. And HTML code, well, HTML part will be new to you. I went over the assignments last time, however, so I'm not going to repeat it again. But it is like it's like a tutorial almost. It's not really even a programming assignment. It's a pretty easy one. But you'll have to install Glassfish or Apache or something in order to get that to work. If you don't have those things installed, it's not going to work because your server's not going to load. But you can run them all from one computer if you want. So let me end this video.